Okay, let's discuss the labs that are in your handout for sensory. Just as an overview, so you have an idea what I'm expecting for you to know. So we can look. So we have the 2-point threshold lab. This one is meant to give you an idea of how dense the receptors for touch are in your skin. So for example, if this is your skin, okay, and if you have a neuron here to detect touch there, another one here to detect touch, okay. If you put 2 points of touch, say in this one area that one neuron is responsible for, you will only feel one sensation. However, if you put it in here and then here, you will sense two things. So that will give you two sensations, because you'll have one here and one here to make two. So the 2-point threshold is done to get an idea of how close you can get 2 points before they're no longer in two different fields. So the closer the 2-point threshold, so the idea is, so you could do, say, if you put green here, say put that one right there, and look at it like here. So if you put one here and one here, that's 2, okay? If we were to put, say, let's make it bigger like this, please, like that. If you were to put one here and then one here, okay, that will be 1. So we're trying for you to see if you can determine how far apart they must be before you're in 2 fields. Okay. So the smaller the field, smaller the distance, that means you have more fields, means more neurons in them. More neurons and also means smaller fields. So the 2-point threshold is to determine how far apart your touch receptors are. Okay. The visual acuity test. Visual acuity is using what's called your Snelling chart to determine how normal your vision is. Usually it's done from 20 feet away. You hang the chart on the wall, back up 20 feet away, and try to read different lines. So if you can read the line labeled 20/20, that means you're seeing from 20 feet away what should be seeable from 20 feet away, which means this is normal vision. If you read the line that says 20/15, that means you're reading from 20 feet away what should only be seen from 15 feet away, which means this is above normal. And if you're 20/30, that means you're reading from 20 feet away what should be seen from 30 feet away, which means this is below normal, okay? So be able to interpret the Snelling chart readings, okay? We'll also do an astigmatism assessment. Astigmatism happens when your lens and cornea are not curved symmetrically, and so the light kind of hits it and goes off at a weird angle, and does not hit the retina at the same time. It doesn't converge at the right time or together, and so we have a chart, like a wheel like this. Okay. This is your astigmatism wheel. Astigmatism. And you're asking them to go 20 feet away, stare in the middle here, and while staring here, all these lines should be equally dark. If they're not, that means you have some form of visual abnormality somewhere in the visual field. And that's all I want you to know is to know how to do the assessment and what you will see if you're normal versus if it's not normal. If it was normal, all these lines will be equally dark. So that is the astigmatism test. Okay, then we have your accommodation test. So this test, well, the wrong thing here. The accommodation test is done to determine if your eyes are able to adjust to something as it comes closer to your face. You know, when something's here, your eyes are a certain way. As they move it closer to your face this way, your eyes must adjust to keep the image in focus. It's called accommodation. Okay, and so here, if this is your face here, and here's a ruler, okay, we're gonna have, say, maybe a little phrase on here, a little phrase on a piece of paper, and we'll move it towards your face until you're no longer able to read what's on the paper. And that's called your near point test, to see how close you can get before it gets blurry. As you age, this near point becomes very far away. For example, maybe a 10-year-old, maybe right here. This probably would be where a 30-year-old is, here. And a 60-year-old would probably be right here, okay? So the older you get, the further away it must be for your eyes to accommodate. Because as you get older, your lens cannot bend as much, curve as much to accommodate what's going on, to accommodate the image in the visual field. Okay. Color blindness, another one we'll do. So color blindness. This one happens because you have 3 types of cones in the retina, and sometimes you're missing one, meaning the gene for it wasn't made. Maybe there's a mutation somewhere in your chromosome, and you don't make that certain cone color, and therefore you can't see all colors. Okay, so color blindness is based on cone loss. Okay, cones aren't there anymore, and you know, so there are 3 types of them. You have your deuteranopia. I forget what they are off the top of my head. Deuteranopia, tritanopia, and protanopia. Okay. This one I think is the most common one because based on loss of S chromosome. This one as well, loss of S chromosome. This one based on loss of chromosome 7, something on those chromosomes. And so depending on which color you're missing here, okay, that will determine what you're able to see. So we'll give what's called an Ishikawa chart, where we have number, maybe in red, the numbers are in red, and we may have different colors around it, and we want to see if you can pick out the number 7 in that field. And if you're missing the red cone, you will not be able to see that. Okay. So that's the Ishikawa test, to test for color blindness. Little books with different patterns and different colors to see what you can pick out. Keep going. Your blind spot test. Blind spot test. Here, in your visual field, in the optic disc of the retina, there isn't any photoreceptors there. And so as the image passes across your field, it will hit that spot every now and then, and you will not be able to see it. That's called your blind spot, okay? So for this one, we use a paper where you put 2 things on there, and you're supposed to say, with the right eye, say with the left eye, you stare at the plus and move it towards your face until the dot disappears. Move it close like this. eventually, like this, eventually the dot will disappear and reappear as it passes through the optic disc. And for the other eye, just close the other eye and look instead of this one. So this one, you close the right eye. So close the left eye here and stare at the dot, and the plus will go away and reappear. So that's called the blind spot test to determine where your blind spot is, or how close it is to your eye before it disappears. Then we have your photopupillary reflex. Okay, the photopupillary reflex. This is the one where we test to see how the muscles of the iris work. Okay, so this is your eye, and this is your iris here. Okay, and this is the pupil. Okay, so we're going to see what happens when we shine a bright light in the eye. Will the pupil get bigger like this, or will it get smaller? Okay, that's the photopupillary test, a test to see which direction the pupil takes. Does it get bigger or smaller with bright light shining in it? And also we want you to test to see if when you shine a light in one eye, if the other eye also responds. So it's called your consensual reflex. We want to see that, if that's also there. That's for your photopupillary reflex there. And for the auditory test, here for auditory acuity, here we just ask you to get something, maybe a little sound, maybe a music playing, and say, start here with the sound, and move it away from the ear slowly until you can't hear it anymore, and measure that distance, okay, for where you can't hear it. Then do the same thing with the other ear, and measure, move away to see how far you can get before the sound cannot be heard anymore. All right, and make sure that you use the same volume on both sides to test to see if both ears are hearing equally well. That's like acuity for sound. Then we're going to do one for sound localization, where this is your head here, ears here. We're going to hold the sound source at different locations, here, and see if you can tell where it's coming from. Usually the sound waves will hit one ear before the other, and that helps to orient you if it's on left or right. Usually when it's up front or in the back or above, it's hard to pick it up depending on where you are, say, too close to a wall. If you're over here close to this wall, it may hit here first, so it depends on what it hits and how you're able to interpret it. But it should be easier from the sides, because it will hit one ear before the other. But just give it a go anyway, see how it works out. And then for conduction hearing loss, meaning something between the outer and middle ear is going bad, so the sound cannot get through into the inner ear. Here we use called the Rhine test. Okay, the Rhine test again. Here, this is your ear. Here, back here at the master process, we will put a tuning fork on it to vibrate here first. So put it here, let it vibrate. So you hit it like this. So it's humming like a vibration hum. Put it here, you hear it hum. When the hum goes away, then put it here. Okay. So first and second here. We want to see if the sound going through bone is better than sound going through air. So this is going through the air. This is going through the bone. Okay. What should happen is that the sound going through the bone should go away, and if you put the fork in front of the ear, you should still hear it. That's a positive test, meaning your hearing is normal. So this should be heard after this one is gone. That's a positive test. If you can't hear this one after this one is gone, that means that you are possibly suffering from hearing loss, from conduction hearing loss. That's the Ryan test job. And then we'll do what's called the Weber test. The Weber test with the Ryan test helps to distinguish between conduction loss versus sensory neural loss. Okay, so if Ryan test says conduction loss or some form of loss, okay, that means and then the Weber test. So in the Weber test, you will again this is your forehead. We're gonna put the fork right here on the forehead, okay, and we want to see if you hear the sound equal in both ears. If you hear equal in both ears, that's okay. That means there is no sensory neural loss. But if you hear it louder in one ear versus the other, then it gets tricky, okay? So if you hear it, let's say the conduction loss test proved that you had a bad hearing in the left ear. And then with the Weber test, the vibration sound should be heard better in the bad ear, where there is conduction loss. In fact, sometimes you can put your finger in your ear and put it right here, and this here will hear it better because the conduction loss will stop you from hearing ambient sounds in the environment, so you can hear it better, the vibration of sound to the bone. Okay, so be able to interpret this, that if Ryan test is positive for conduction loss and Weber test has the same issue in the same ear, then that is confirmation that is hearing loss. But if the Ryan test says that you have normal conduction hearing and the Weber test says that one ear is not as good as the other one, then the Weber test is telling you that the ear that's bad will be the ear that's having a sensory neural loss. Figure that part out. It's a bit tricky. Okay, that's an overview for your sensory lab. Thank you.